Okay, well, unfortunately, because of our time limit, we are not going to be able to accept questions, but thank you for the talk. So our next speaker is Syed Fadayi, who is a researcher at the University of Surrey in Guildford, and will be presenting LEOScope, or LEOScope, building a global testbed for low Earth orbit satellite networks from CCR in July. Thank you.
Thank you for the introduction. Hello, everyone. I said I'm Syed Fadayi. I'm going to talk about the LEOScope, or by the other meaning, Planet Lab for Starlink. To begin with, wow, I wouldn't expect this. Huh. Okay, this is weird. This shouldn't be like this. I don't know why. I've checked it before that. Anyway, so why need a testbed for the LEO satellite networks? Most importantly, we are talking about a fairly new technology. We can say it's not fresh out of the oven, but it's roughly it can be considered as a new technology. For example, you want to test new protocols, or you want to, like Zekile at this SIGCOMM' that worked on the LEO CC, and you want to consider doing measurements over the congestion controls. Or you want to have, I'm gonna tell you an example. It was like, I think it was last May 2024, I was at a birthday party, and Nishan sent me a post over the Slack about, I think it was a BBC News regarding the solar storm. So what I did, I didn't have access to any laptop. I needed my measurement to constantly running at the moment. So what I did, I used the LEOScope testbed website interface to schedule my measurements with my phone without any challenges, and I had my data. Or if you want to have your scheduling, if you want to schedule your experiments on a cron or interval basis, for example, you want to do measurements over the WebRTC, streaming, or doing iPerf, on an interval basis, or even you want to have your telemetry, gRPC telemetry data from the Starlink. But as a testbed, why it needs to be global? This is the same example that I was presenting this morning, and it is a solar storm. Basically, LEO satellite will provide different class of, or different category of performance in the different latitudes of the Earth. For example, the performance you get in Nigeria, it's not the same as, it's not even comparable to the performance in London. So considering this different classification according to the location, we need our testbed to be global. But comparing to other testbeds, what are the other options? Having the options that I discussed as the features for LEO-specific testbeds, and starting with the built-in telemetry trigger base and user-defined experiments, data access, and purpose. Talking about these testbeds that are existed, MLab is totally different. Whenever, as a user, you have your speed test running, you will have your result, and you can download you can get the speed test results from MLab. That's a totally different story. For Planet Lab is mostly about terrestrial network and testing new network deployments. EdgeNet also has the user-defined customizable experiments, but the data access is restricted exactly as Sam knows. But among all these, we have RIPE Atlas, which is mostly being used by researchers in LEO satellite networks. The downside of the RIPE Atlas, we can say, is the lack of having customizable user-defined experiments. As said, for example, you want to have weather effect experiments or the congestion control mechanisms. What would you do in RIPE Atlas? So basically, user-defined experiments can be important. But LEOScope, as said, it will provide you public access and has all the features for LEO-specific measurements. Going forward, go in deep detail into user-defined experiments. This is an example of how we have, for example, this is an IMC 2021 example that we have done in our team. It says, I think this slide is not updated as the last version, sorry though. For comparing the Starlink to the Wi-Fi or the terrestrial measurements, for example, here we have BBR, Cubic, Reno, and Vino, and Vegas, and you want to test it with the terrestrial. What would you do? Or this is the different metrics, like considering different weather conditions and find the correlation between the weather conditions and the page transit time in your browsing experience. LEOScope would help you on solving or running your measurements on the both use cases. That's why user-defined experiments are very important. But as two most important elements of our testbed, as researchers and volunteers, we need to care the most about them. Unfortunately, not all the world have the access or the proper access to the satellite setup. That's why we haven't yet put any subscription for researchers to use the testbeds. As a researcher, you can request for access and have your own profile on the testbed and run your measurements. On the other side, regarding the volunteers that providing node to the testbed, we should care about them. For example, if primary, like Nishan, that has volunteered his node to the testbed, if he or his family wants to use the node, we shouldn't use all the bandwidth possible on the Starlink that he has. So the question would be, to answer these questions, LEOScope provides a couple of unique features that are practical. Starting with the scavenger mode to protect our volunteers. As you can see in this figure, when there is a measurement going on and we are talking about the upload throughput as an example, and the primary user as the red line starting to use the main node, for example, for a Zoom meeting during the night, what you're expecting of a testbed to do for you? Basically, the testbed will stop the measurement automatically and reschedule it to a later time according to the bandwidth. Or going further with the other unique features, basically the cron mode is about allowing you to run your measurements according to the pre-scheduled, with the predictable events, such as when is Starlink going out of sight, or if you want to test a 15-second global reconfiguration in the Starlink network. At this example in this figure, we are comparing the distribution between the times that we don't expect any reconfiguration in the network with the times that there are 15-second basis global scheduler. As you can see, that's why this is gonna be a unique feature for LEO-specific use case. Or the other one, as I mentioned in the early steps of the presentation, the trigger mode. This is another example, again, related to the weather conditions, and you want to test your throughput during different weather conditions. Or you want to see if your elevation or the azimuth degree of your node is in a specific condition. Basically, the trigger mode will work on an IFTTT condition. If this condition is going to satisfy, you run my measurement automatically according to the condition. And one of the other important features can be the gRPC data coming from the telemetry. These are two screenshots from the LEOScope dashboard, which is online. When you check the dashboard of the LEOScope, you'll see a map of the activated node from North America down to Antarctica. And what you can see there, it will collect the gRPC telemetry data for you. And what are gRPC telemetry data? Basically, if you want any information regarding the SNR details, dish connection, azimuth or elevation degrees, upload and download throughputs, despite of it's not so reliable, popping latency and drop rate, hardware or software updates, or dish obstruction maps. The below figure is an example of the automated plot on the dashboard, which you can see the data of each of the active nodes over the testbed in real time. Going forward, how we did it, or better to say how we are still doing it in terms of the architecture. I set the example about the solar storm, right? When I scheduled my set of experiments with my Docker containers as ready with my phone. LEOScope provides a website interface. When you log in into the website you can use. Basically, it will be some fields that you can schedule your measurement over, but what you can run. Anything that could be fitted into a Docker container can be run into, it can be scheduled into a LEOScope. We get the Docker configuration and plus the Azure cloud storage that you have. Because when we schedule the experiment through the cloud orchestrator into the connected node or the specified node that you want to run your measurements, the results would be wrapped up with the gRPC data coming from the node's location, and the wrap-up data would be compressed and would be sent to your Azure cloud storage. We normally don't save anything, and the results are on your cloud storage. It is totally distributed. But as the experience of running a testbed is not about science always. Sometimes it can be about artistic side of it. For example, for the West Virginia node, during the weekdays, it's for the node is belong to the Virginia Tech's head that has been volunteered to the testbed. During the weekdays, the node is off, taking a full nap, but in the holidays, the node getting back because of the power cut in the working days. Or in the Germany that we have multiple nodes. I don't want to mention directly, but since the node is behind the university firewall, we always have issue of bringing it back online, and like new policies coming up always, and we need to follow it up. Or for the Nigeria. So basically one of our team members, who is Abdul and active in the field, has a brother in Nigeria back home. They have volunteered a testbed, a node to the testbed, and they have like massively crazy power cuts every day, every hour, and we need to constantly follow up with them to bring the node online. Or finally getting to the Nishan's node. As he says, he has a small yard, but I don't know why it's always full of obstructions. I can imagine it as a jungle, I can say, but this picture is one of the images coming from the Nishan's node, and that banana is, I think, his favorite fruit, or wanted to show the size of the setup. Going forward with the experience that we have with the testbed, where are we now? Right now we are active in 5 continents out of 7. As said, from north of Canada down to the Antarctica, and we are active in Europe, multiple locations, North America, Africa, and Antarctica. And we are seeking for and demanding for any volunteers node into the Starlink or even OneWeb. If you are interested, please get in touch so we can add your node to the testbed, and basically all around the world, not on these 2 only continents. And I want to use this opportunity to again thank SIGCOMM' for the presentation and the nomination, and appreciate our volunteers who've done a lot with the cooperation and doing with the volunteering their node to the testbed, which you can see their list. Thank you. And if you want to access LEOScope, you can scan the QR code. Thank you.
Thank you very much, and one round of applause for the entire session for all of the authors. Okay, we are at our final, so maybe Marilia and Christian can come up. And this is I will turn it over to them, actually.